this, and thank you to the organizer for enabling me to give this speech. I highly appreciate Daniel and Itai, first of all. So I would like to present one of our first technology, which is called StayPrime. So the idea with EntoPrime, as you also mentioned, Daniel, is to create innovation for efficient and sustainable BSF farming. And today I will give a very short presentation of the StayPrime, and then I will go through the aim of the study and the lab trials that we have conducted, as well as some farm trials that we have previously conducted with a big farmer in Germany. And then we'll have some conclusion and perspectives, and if time allows, we'll also have some questions. So this StayPrime is really a product that can stop the development of insects at any time, and we have actually tested with 3 different species. The black soldier flies, this will be the focus of the speech today, but also we have tested with mealworm and with Drosophila. And StayPrime can easily be used for the neonate stage, so after larvae are hatched from the eggs within 24 hours. At the juvenile stage, so anything really between the 1 day and 7 days, let's say, of larval age, depending on temperature and so on. And also the post-harvest stage where they are still actively feeding, so they haven't entered the pre-pupa stage or the pupation stage as it's called, and people will harvest them. So the idea of using StayPrime is really to enable farmers and research or scientists like yours, like yourself, to create buffer capacity so you can better plan your experiments or your production settings, and also to ensure efficient shipment between different universities or different research centers or different farms. And to a certain extent, we have also seen in the past that this can be used to enhance production performances, although we have like quite mixed, let's say, results on this. So I will stick with, the default. There is no difference from the control. So now when it comes to the presentations that I will give, it's really about this StayPrime product that transformed the insect supply chain with the first ever growth rested product for farmers and scientists. And the idea behind it is really to show you some of the results from validating this StayPrime product to arrest black soldier flies neonates and black soldier flies juveniles. And you can see those little pouches over here. So those are actually the products that I've been talking about. So we have run several trials. So one of the lab trials was actually focusing on arresting neonates, and for this one we used 24 hours freely hatched neonates, and we arrest them for 7 days at room temperature. We had about 1 gram per container or vial, as we call it, and then we used 3 different vials just to test different packaging solutions for this particular technology. After we have arrested them for 7 days, we have also feed them for 7 days when we use a feed of wheat brown mixed with chicken feed in a proportion of 50-50. And then we have actually nursed them at 28 degrees Celsius under stable climate conditions. We have, at the end of the nurturing, we have assessed survival rate, average weight, and the juvenile biomass being produced after nurturing. In another experiment, we look at juveniles, and here we use 5 days old larvae. Over here, we arrest them for 2 weeks and also for 22 days. So roughly speaking, 3 weeks. Again, the arrestment was done at roughly speaking 20 degrees Celsius. So this is lab or room temperature. We haven't controlled for having a stable temperature in that regards, neither for the neonates arrestment period. And then here we actually use different densities. So we use 87,000, for example, per packages. And you can see here in the left side of the juvenile setup, you can see the pouches that we have used. And then we also use bigger pouches that can accommodate 250,000. So the idea was actually to see if we can, arrest, let's say, a kilo of juveniles or so, so you can have bulk arrestment in that regards. We after that only use the 87 because our capacity is quite limited. It's a research facility, so it's not a production setting. And in that regards, we choose to go for rearing only the 87,000. And then we have reared them for 7 days. We fed them on chicken feed and maintained them at 28 degrees Celsius. We assess the following traits, so survival rate, and juvenile weight before and after arrestment for all the treatments. And then when it comes to the rearing part, we have assessed the larval biomass and the feed conversion rate after rearing together with the control. So for the neonates trial, we use 3 different vials or tubes, or depending how you want to call it. In that regards, we use a vial, a falcon tube, and then a shot glass. And then we look at the juvenile's weight, and what we have actually seen is that the juvenile weight after nurturing, so everything was actually measured after nurturing because it was easier, was quite consistent between the vial and the falcon tube, but it was actually higher for the shot glass. And the reason why the shot glass was actually higher, it's simply because the survival rate was also quite low, so it was only 65%. Bear in mind that those survival rates were actually measured on weight, they were not actually measured, they were assessed based on weight or using a weighing approach. So in that regard, you can see that this is an estimate. But what the result says here from the survival rate is that for both the vial and the falcon tube, we can actually enhance or we can ensure a high survival rate, while for the shot glass, we actually have a lower one. And one of the problems that we actually had with the shot glass during this particular experiment, it was that the neonates had a tendency to escape from the shot glass. So we had like neonates all over the place. That was not the case for the vial or either for the falcon tube, which was quite interesting. Furthermore, we also look at how many grams of juveniles we can actually produce in these nurturing settings. And over here, we could see that we produce roughly about 1.1 kilos of juveniles for all the treatments. Those were actually a bit older because, I mean, the nurturing was done for 7 days. Then when it comes to the juveniles results, over here we had 87,000 juveniles that you can see on the x-axis. Oh, sorry for that. And then 250,000 juveniles. So we had 2 different temperatures over here, 2 different densities. And if you look at the juvenile's weight before and after arrestment, so, just before we arrested for a week, and then after arrestment, we could see that the average weight was actually quite similar for both density, which was quite nice. And then further up, we also looked at survival rate after arrestment, and we have found that the survival rate was quite high after 2 weeks. However, we also decided on, okay, so we look at 2 weeks, why not pushing it a bit more and see what will happen after 22 days. And we have seen that, the 250,000 juveniles that we have actually kept for a longer arrestment period had a tendency to have a lower survival rate after 3 weeks. However, we also observed that the pouches started to dry out. So this could be one of the problems that lead to lower survival rate in this particular treatment. And then we also look at the larval biomass. So here we actually have decreased the amount of larvae going in the reproduction, and that's something that I haven't mentioned. And that was simply because we had very small crates that we could use for production. Nevertheless, so we selected same amount of larvae, 2,000 larvae for each of those treatments, and we placed them in small containers, and we fed them. And as you can see here, the larval biomass was actually quite similar between the 14-day surveillance and a control group that we have used during the same period of time. I have to specify that there is a tendency of increasing the biomass production, but this is not statistical difference. So I will have a doubt on believing that there is really an effect in this particular experiment. And then the same goes for the feed conversion rate. It was quite similar when it comes to the two different treatments. Lastly, we also have a, let's say, longer trial with the farm. Actually, it was production batches that just to see if we could actually deploy this technology. And here we have used, we actually work closely with our partner in Germany, Farm Insect. We have produced about 51 batches of larvae being arrested in StayPrime. And then they have actually shipped out those juveniles. This is for juveniles production, and they have shipped out those juveniles juveniles containers harvested in StayPrime to 3 different farms. And they ship them under regular conditions. They choose to harvest them for 7 days because they can ship once a week. And then obviously they had their own growing conditions with a specific feed that is formulated by the farms. They had about 80,000 juveniles per container. And then we have actually looked at larval biomass, survival rate, and feed conversion rate. So over this period of time, which was roughly speaking about 1.5 years, we have produced a total of 100 tons of larvae. This is the fresh weight, of course. And it was quite nice because we have a first production step where we only tackled one farm and it went quite well. And then we have actually upscaled that to 3 different farms to see if we could actually deploy this technology with them. And we have successfully deployed that and use it in 3 different farms. We also look at overall, let's say, feed conversion rate for StayPrime in step 1, so at 1 farm, and then StayPrime in step 2, so at several farms. Also compare that with the control. And what we have actually seen, it was that the both feed conversion rate and also survival rate were quite similar between those treatments. And survival rate was quite high. So what does that mean? I mean, control and StayPrime look the same, but I mean, for this particular, let's say, setting, our partner could actually ship out larvae once a week and then have a truck going around different rearing sites or different farms, rather than shipping out to individual farms several times a week. So that could actually help them out to reduce the cost when it comes to weekly shipments and the amount of personnel being used at the breeding site, but also at the farm site. So in conclusion and perspectives, we have successfully arrested black soldier flies neonates for 7 days, and currently we run experiments for a targeted 14 and 21 days arrestment. Just checked them yesterday and they look quite fine, and I'm quite happy to see how that will turn out. Then we have successfully arrested PSF juveniles for 7, 14, and 22 days at different densities, both at lower density, but also at the bulk density. And then we have actually ensured high larval performances using this StayPrime while reducing shipment and storage cost. And obviously, we are very happy to find out new collaborations and share ideas and ping pong when it comes to ideas, so we can help out this industry. I would also like to take this opportunity to thank some of the funding bodies that have, help us out to conduct those trials. So that will be the Innovation Fund Denmark, where we run an InnoFounder, and also the GUDP, the Ministry of Food, Agriculture and Fisheries of Denmark, that help us out with the funds for the farm trials. And I would also like to thank our collaborators in the HIGA project, where we work together with some very nice people. And I will be more than happy to have any questions. Thank you very much.